Al Gore. Deep sighing.
Texas. That's what a governor gets.
Lockbox supplying.
Ironclad lockbox. In a lockbox.
Gravity defying. Gift to climate protection. But how does climate change work? Well, let's take a look. The Earth's atmosphere is made up of 6 layers: the troposphere, the stratosphere, the mesosphere, the thermosphere, and the exosphere. And within the stratosphere is the infamous ozone layer, called such because obviously it contains ozone molecules, or O3. Ozone is a very funny molecule because obviously oxygen molecules are normally diatomic. But because of the height of the stratosphere, there is lots of UV radiation, which break down O2 molecules into individual oxygen atoms. And because UV is so high energy, it creates O3 molecules. But oxygen very obviously has a valency of 2. So why does this happen? As you can see, the oxygen in the center has 3 bonds around it. But how is this possible? It's to do with the positive and negative sign you can see on the 2 oxygen atoms. The overall dipole means that the charge is shared between the molecule, also called resonance, and you see something similar in things like benzene rings. This creates a very electron-dense area, which leads us to our problem. CFCs. No, not this one. What? No, not this one either. Okay, yes, good. Chlorofluorocarbons. Used as propellants in aerosol, refrigerants, and air conditioning. It was by all means a wonder chemical. You know, like asbestos. Or lead. So what exactly was the problem? Well, here comes our old friend UV light again. When I said it was high energy, I wasn't kidding. It turns out it used to tear the chlorines off of these CFCs and turn them into free reacting radicals. And in turn, these radicals would react with ozone and leave us with just oxygen. O2, very obviously, isn't ozone. This led to a hole in the ozone layer, which is very much a phrase you might have heard when you were younger, but less nowadays. At the time, it was a huge problem, because ozone absorbs UV rays. And more UV rays meant an increase in things like skin burn and skin cancer, cataracts, which can cause people to go blind, and in certain places, crop blights and famine. Once these effects had been proven, the world had to think of a solution, and quickly. And the burden fell on the shoulders of everyone's favourite francophone country, Canada, who, in 1987, created something called the Montreal Protocol, which was signed by every country on Earth at the time. It was basically a call for the ban of CFCs. But Skunky, I hear you, loyal viewer, ask, how are we going to tell the computer science students, apart from the rest of us, if we can't have propellants for our deodorants? Well, worry not, viewer, for there is something called HFCs. No, we can't do this bit again, it won't be funny a second time. HFCs are exactly the same as CFCs in that they're non-flammable, non-toxic, and very small molecules, except for, rather than chlorine, they have hydrogen in them. And because hydrogen is ever so slightly more reactive, it breaks down before it reaches the stratosphere. And because of this change, ozone depletion has all but stopped, and the ozone layer is on its way to recovery. So we did it. We solved climate change, everybody. But no, HFCs, like all the other wonder chemicals, had an adverse side effect. But to be fair, it's not UV's fault this time. Instead, it's its cousin, infrared. When the Industrial Revolution began, people believed that byproducts like CO2 would just go directly into the ocean. But what's obvious now is that's not the case, and instead they go into the atmosphere, where they absorb infrared radiation. As you can see by these IR spectrums, they absorb a lot of infrared light, which means infrared radiation re-radiated from the Earth back out into space is absorbed by our atmosphere. And just in case there's any deniers watching this, yes, I know ozone and oxygen are on there, but we do need some greenhouse gases, because the average temperature on the surface of the Earth at the moment is about 15 degrees Celsius. Without any greenhouse gases at all, it would be -18. Unlike the ozone layer, this one doesn't have a happy ending. So what can we do to help? An obvious answer is planting trees, but there are other things to do. Try and buy your produce locally. Reducing the amount of food miles on it can really reduce the amount of CO2 put into the atmosphere. Finally, lobby your congressperson, lobby your MPs, lobby anyone in a position of power to try and create renewable energy sources. Things like solar panels, wind turbines, even nuclear power is a massive advantage in the fight on climate change. That brings us to the end of this video. I really hope you enjoyed. Please remember to like and subscribe, and feel free to join me next week for a video on acids and alkalis. Thanks.